This morning, NASA scientists revealed a discovery that could change everything we know about life in the universe. And as the news spread across scientific communities, newsrooms, and social media platforms, it became clear that this was not just another distant world discovered in the vastness of space, but a place that might, for the first time in human history, force us to reconsider whether Earth is truly unique in its ability to support life. The planet in question, designated as K2315b, had been spotted years earlier by the Kepler Space Telescope but had remained largely unnoticed, buried in a backlog of unprocessed data, until the James Webb Space Telescope's infrared instruments confirmed something astonishing. This world, orbiting a red dwarf star located about 124 light-years away in the constellation Leo, appeared to have an atmosphere dense enough to retain warmth and possibly liquid water, a discovery that instantly catapulted it into the category of potentially habitable exoplanets. Alongside famous names like Proxima b and TRAPPIST-1e, what set this one apart, however, was not just its location in the so-called habitable zone where temperatures could allow water to remain in liquid form, but the chemical composition detected in its atmospheric spectrum, faint but undeniable signatures of methane, carbon dioxide, and most intriguingly, dimethyl sulfide, a molecule that on Earth is produced almost entirely by biological processes such as marine plankton activity. And while scientists cautioned that non-biological processes could, in theory, create the same compound, the statistical likelihood of such an abundance forming without life was so small that it immediately became the subject of intense debate in labs and conferences worldwide. In their press briefing, Dr. Elena Vasquez, the lead exoplanetary scientist at NASA's Goddard Space Flight Center, explained that the Webb telescope had captured multiple transits of K2315b across its host star, each time revealing more details about its atmospheric composition, surface temperature, and possible cloud formations. And in the high-resolution data, subtle light curves hinted at weather patterns that could suggest the presence of oceans or at least large bodies of liquid, meaning this planet wasn't just a frozen rock or a scorched desert, but a dynamic, possibly Earth-like environment. The excitement in the room was palpable, yet tempered by scientific caution, because, as Dr. Vasquez reminded the audience, we have been misled before. In 1976, for example, Viking landers on Mars produced ambiguous chemical readings that some interpreted as signs of life, only to be reinterpreted decades later as chemical reactions unrelated to biology. And yet, despite the caution, the sheer number of converging indicators on K2315b made it impossible to ignore the possibility that microbial or even more complex life forms could exist there, perhaps thriving in oceans beneath skies tinted orange by the red dwarf's light. The planet itself, NASA scientists noted, was only slightly smaller than Earth, with a gravity close enough to ours that human exploration, at least in theory, would be feasible, though the distance, more than 700 trillion miles, would make direct travel a monumental challenge with current technology, requiring thousands of years using conventional propulsion. But that didn't stop private aerospace companies from already imagining concepts for robotic probes that could reach the system in decades using experimental nuclear fusion drives or light sail technology. Meanwhile, computer simulations run by planetary climatologists suggested that K2 to 315b might have large continents interspersed with shallow seas, and if its axial tilt was stable, it could maintain mild seasonal variations rather than the extreme swings seen on many exoplanets, creating a stable climate over millions of years, an ideal cradle for life to evolve and diversify. The discovery has already triggered a wave of proposals for new observation campaigns using not just JWST, but also upcoming telescopes like the extremely large telescope in Chile and the Love Space Observatory concept, each of which could probe deeper into the planet's atmosphere, looking for the holy grail of exoplanet science, a combination of gases like oxygen and methane together that would almost certainly indicate biological activity. But what truly captured the public's imagination was not just the science, but the possibility that somewhere right now, under a dim salmon-colored sky, alien life, perhaps no more complex than algae, perhaps as advanced as intelligent beings, could be gazing back at their own sky, wondering if they are alone, just as we have for millennia. In classrooms around the world, teachers use the announcement to inspire students to imagine the future of space exploration, while philosophers and theologians reignited debates about humanity's place in the cosmos, and already online forums were buzzing with theories, ranging from careful scientific analysis to wild speculation about interstellar diplomacy, ancient alien contact, and the ethics of one day visiting such a world. Yet beneath the excitement lay a quieter, more profound realization that in finding a world like K2315b, we may be inching toward the answer to one of the oldest questions ever asked. Are we alone? And if the answer is no, then the history of our species is about to enter an entirely new chapter, one where Earth is no longer the sole oasis in the cosmic desert, but part of a much larger, more mysterious, and more beautiful network of life, stretching across the stars. And in that possibility, there is both wonder and responsibility, because if life exists there, it too would be precious, fragile, and worth protecting, just as we must protect our own planet. A reminder that the search for life out there is, in many ways, a mirror held up to life here. As the press conference continued, the mood began to shift from excitement to determination. NASA officials confirmed that the discovery of K2315b was not the end of the story, but the beginning of a new mission unlike any before. Plans were already being drawn up for a coordinated effort between multiple space agencies, NASA, ESA, JAXA, and even private companies to study this planet in unprecedented detail. While human travel to K2 to 315b was impossible with current technology, there was talk of designing a new class of interstellar probes, capable of reaching nearby stars in decades instead of centuries. These probes, powered by nuclear fusion or massive solar sails, could one day capture high-resolution images of its continents, oceans, and perhaps even signs of life on its surface. Asterisk behind the scenes. Scientists were working around the clock to refine the atmospheric readings. More data from Webb was scheduled for release in the coming months, and rumors were already spreading that early analysis hinted at something even more shocking: faint chemical patterns in the light spectrum that could suggest large-scale biological activity, perhaps even plant-like organisms affecting the atmosphere the way Earth's forests do. If confirmed, this would be the first direct evidence of an active biosphere beyond our solar system. Asterisk meanwhile, the discovery began, sparking conversations outside of science. Politicians debated funding for faster-than-light research. Religious leaders discussed the spiritual meaning of life beyond Earth. Artists, writers, and filmmakers began imagining what it would mean to one day see the skies of K2 to 315b with our own eyes. Across social media, a single question trended worldwide: if we are not alone, what happens next? Asterisk Dr. Elena Vasquez, closing the conference, left the world with a sentence that would echo for years to come. When we look up at the night sky, we have always wondered if someone might be looking back. Today, for the first time, we have reason to believe the answer might be yes. Asterisk, and so, humanity stands on the edge of a new era. Somewhere light years away, beneath a salmon-colored sky and across alien seas, Life, simple or advanced, may already be thriving. Whether we meet it in our lifetime or leave that moment to future generations, the search for K2315b will forever remind us of a truth. We are only beginning to understand. The universe is not silent, and the story of life is far bigger than Earth alone.